Now we're going to get into what I call design patterns for being able to deal with an event-driven system. We're going to start with the different ways in which you can receive data. The perspective here is that I'm running some sort of domain that I need to represent what is a synchronous type of service. I'm calling a RESTful endpoint, I'm trying to get information. So the idea is I have to balance asynchronous with synchronous behavior. And in each of these domains, there are different options, but fundamentally, it's about how does one domain communicate with another and using an entire domain to interact with a third party. And by third party, I mean something you have to communicate with, whether it's a service for sending text messages or it's a Department of Energy for getting fuel prices. It is a third party outside of your control. In option A, for dealing with that example, the idea is that third party is capable of calling some endpoint on its own. This makes an event-driven approach really easy because you're relying on the third party to be online and calling some endpoint. And this is in option A. In option A, this is saying that the third party is going to be able to have to call this endpoint, and it's at that endpoint that you're just going to go ahead and store the data in some form. And then from a perspective I need to get the data, you're just going to have some other endpoint call the data when it needs to get it to retrieve data from your third-party store. This models an event-driven perspective. However, there is no event bus. It's really not an event-driven solution, but it is an option for getting data from a third party in some form that's event-driven because the third party itself is only calling it when an event happens that triggers it. Option B is similar, except in getting the data and directly storing it in a database. Our endpoint in this case is getting the message from the third party and just putting it on the event bus and being done with it. The advantage over this approach with option B instead of option A is that in option A, we're relying on what is really a transaction for I put it into a database of some sort or data store of some sort, which isn't an event bus. And so really you have what is a transaction between the third party and this data store. The advantage of the event bus is that it's a slightly faster operation because the third party calls an endpoint and all that endpoint has to do is dispatch it to an event bus. There's no transformation of the data. We're not storing it in a database. You're keeping the event in its raw form on the event bus, where you're then relying on another application to listen to that event bus and turn that into a data representation that's needed to expose an endpoint in a meaningful way for another domain to be able to get data out of it. The final option is option C, in which in this case, consider that if we're dealing with a large amount of data, it may not be really feasible to have to call some other endpoint to get the information. There may be too much data. It could be thousands of records. It's something which you're now going to take the need to process it and move it into the other domain itself. So our third-party domain in this context, when it comes to receiving data, we're still relying on the third party to call our endpoint. We're putting it on the event bus, but that's where our third-party domain ends. What this means, though, is by ending it at putting it on the event bus, that means the processing of the event now becomes the responsibility of the other domain using our third-party domain. So it has to be listening to the event bus for the events it needs, and then it's going to have to aggregate the data in its own way that's then used by some other service. The advantage of option C over option B is that it can deal with a lot more data because we're not making essentially REST calls over the network. We're relying on data just coming in directly from the event bus and processing it in some meaningful way within inside our other domain. The downside of this option, though, is that you redundantly have to process all of the individual events. And the other option, we were relying on our third-party domain to essentially handle the aggregation for us and expose the data in a similar way. But in option C, we're having to do a custom aggregation of that event and then storing it on our own. In a lot of ways, this can defeat the purpose of having a third-party domain in the first place because most of the logic actually sits inside the data aggregation.